In this video, we'll look at solving equations that also have an initial condition. Step 1, we want to separate the functions. So let's divide both sides by e to the y. And at the same time, we can multiply both sides by dx. Next, we will integrate the left and the right. On the left, we get negative e to the negative y, and on the right, we get 1/2 x squared, and we'll add our constant on the right side. Now let's use the initial condition y of 0 equals 0. We'll plug those values into the equation we just found. Negative e raised to the negative 0 equals 1/2 0 squared plus c. This means that c is equal to negative e to the 0 will be negative 1. Now we can rewrite that equation. Negative e to the negative y equals 1/2 x squared, and we'll replace that c value with what we just found, negative 1. Next, let's see if we can solve for y. We'll need the natural log, so we need to start by dividing both sides by negative 1. Make that base positive. Now we'll take the natural log of both sides. We'll get negative y equals the natural log of negative 1/2 x squared plus 1, and then divide by negative 1. Y equals negative natural log of negative 1/2 x squared plus 1. So we now have the solution that has the given initial condition. In this example, we want to find an equation of the curve that passes through the point 0, 2, and whose slope at xy is x divided by y. Since the slope is x over y, we can think of that as dy dx. dy dx is x divided by y. Next, we'll separate the functions. So let's multiply by y on both sides, and we'll multiply by dx on both sides. Essentially cross multiply to solve the proportion. Integrate the left and the right side. 1/2 y squared equals 1/2 x squared plus c. At this point, let's use the initial condition. Y of 0 is 2. So we'll plug that information into what we just found. 1/2 times 2 squared equals 1/2 times 0 squared plus c. 1/2 times 2 squared is 4, so that will be 2 equals, that term is 0, so we just get 2 equals c. Now using that, we'll plug that back into the equation we found from earlier. 1/2 y squared equals 1/2 x squared. C we will replace with 2. Now that we've replaced the constant, let's see if we can solve for y. We'll start by multiplying everything by 2. Y squared equals x squared plus 4. And then to solve for y, we need to take the square root of both sides. And y is equal to the square root of x squared plus 4. Now, typically when we take the square root of both sides, we need to add plus or minus. But in this case, we're only going to deal with the positive version. And the reason we know we can deal with just the positive version is our initial condition, y of 0 equals 2. We're dealing with values that are bigger than 0. So we'll stick with just the positive version there. Next, let's find the function f such that f prime of x equals x times f minus x, with the initial condition f of 0 equals 2. To begin this one, I'll rewrite some of those terms to help us solve and separate the functions. F prime we'll rewrite as dy dx. That's equal to x. F of x we can write as y, then minus x. Now our goal is to separate the functions, but in order to do that, we need to do some factoring here to get that y out of that expression. So dy dx we'll just copy, and let's factor out an x. That way we can separate those two functions, x and y. At this point, we can divide by y minus 1. We'll do that on both sides, and we'll also multiply by dx on both sides. Now that we've separated the functions, we will integrate. Integrating on the left side, we get the natural log absolute value of y minus 1. And on the right side, we get 1/2 x squared plus c. Let's use that initial information. F of 0 equals 2. That will give us natural log of 2 minus 1 equals 1/2 0 squared plus c. We'll get natural log of 1, which is just 0. 1/2 times 0 is 0, so we get c is 0. We'll use that now to go back to the equation from earlier down here. Natural log absolute value of y minus 1 equals 1/2 x squared, and we now know that c is 0, so plus 0. Let's see if we can solve this for y. Since y is inside the log, we'll need to exponentiate both sides. So we're going to have e raised to the left side, e raised to the right side. That will allow us to drop down the arguments, and the log is now gone. The right side we have e to the 1/2 x squared. Notice that e to the 1/2 x squared is always positive. If you think about what the graph of that looks like, it's always positive. So that means this piece on the left side must also be positive. So we can drop the bars at this point and just make it y minus 1 equals e to the 1/2 x squared. Now add 1 to both sides. Y equals e to the 1/2 x squared plus 1. We have our solution.